So we are going to cover two topics today. Two topics, Core Location and MapKit. Now, so the two things we're covering, location-based services. In other words, the first bit is, where are we? So if you've got an API which you built for 305, which allows you to have latitude and longitude and actually have geodata in your API, you can use location-based services to capture the latitude and longitude of the device. So when you post or put data back on the server, you can pass that data back to your API. The second bit is all about Apple Maps. So they're two separate but related subjects. First one is, where's the user? Physically, where are they? And the second one is, once we've got all this geodata in our system, how can we display it? How can we display it in a meaningful way? So, location services, the first thing we need to understand is we need to add some frameworks for this. Up until now, we've used a couple of frameworks. We've used Foundation Framework, we've used UIKit, haven't we? Looking blank books because they were there already, you didn't even need to know about them. If you select your project, your blue little icon, you get this little section in the middle called Frameworks. And the ones you have to start with are the Foundation Framework, which is your strings, your NS dates, NS integers, all those sort of core values, your arrays, NS mutable arrays, NS arrays, NS dictionary, NS mutable dictionaries, all those sort of core classes you need to be able to program. UIKit is all the widgets, this sort of NS, the UI text view, the UI table view controller, UI table view controller cell, all those sort of UI table cell, all those controls. Core graphics is how it does the animations, all the nice animation stuff it does. It needs that to do all these nice funky sort of animations and transitions and things. You get those for free. If you want to have more, you have to click on the plus button, and if you want to find out where the user is, you need to import Core Location framework. And if you want to plot things on maps, you need the MapKit framework. And you simply just click on plus, select from a big list, and add them to your project. It's as simple as that. If you do that, you need to import them, as I'll show you in a minute, like so. So if I'm using the Core Location framework in my header file, I must import the framework. It's not done for me. So you can see, because it's a framework, not just a header file, you get this little square, this little angle brackets around it. And you must import the frameworks. Shoot. Okay. Now, this is the key to finding the current location. You have an object called ACL Location Manager object. You need one of those for your application, and it's a singleton. So basically, you have one to manage the whole application. So what I tend to do, as with most things like NS mutable arrays and NS datas and all these sort of things, I create a private property. Then I can access it through the getters and setters, can't I? Don't forget to synthesize, obviously, because that's important. So I create my CL Location Manager, which I'm calling Location, and that's going to control access to the GPS chip, access to the cell tower triangulation, access to the Wi-Fi triangulation, and all those services. So this is how we find our location. So we allocate our CL Location Manager like we do for most other objects, and then we've got a series of properties we can set. The distance filter, is, let's imagine you want to track someone moving around. How far do they have to move before it grabs their location again, before it captures the location and sends a message back? So if you set it for 100 meters, you'd have a series of lines and dots every 100 meters or so. If you set it for 1 meter, you'd have a much smoother path, but obviously it's going to suck the battery dry a lot faster. The desired accuracy is the key here. I'm saying that you've got KCLL location accuracy. You've got 100 meters, 10 meters, 1 meter, 1,000 meters, kind of every tenfold each time. The smaller you make that number, the more it's going to drain your battery. So if you really care about which town they're in, you might say 1,000 meters. If you care about which street they're in, you might say 100 meters. You see what I mean? If you care which building they're in, they might say 10 meters. And the idea is, if you want a very loose accuracy, it uses the cell towers for triangulation purposes or Wi-Fi hotspots. The more accurate you need it, the more it uses GPS to supplement that data. And the more it uses the GPS chip, the faster your battery is going to drain. So, and the idea is, there's a special method called start updating location, and that switches on location services. And the little arrow appears in your status bar. There's also a stop updating location, which we'll talk about a bit later, because sometimes you only want to use it occasionally, don't you? You might have, you don't want it all the time. If the view is hidden in your application, you might say, actually, I don't need location services, I'll just switch it off again. So the idea is, we want to make sure we only use location services when we desperately need the person's location. If it's about which lecture they're in, you might have a timer which runs an hour, just pops up and fires off a message, fires off a request for location. Or every 15 minutes, you can do that. If you're tracking someone around a building or around the town, you might say every 5 minutes you want to grab the location. But really useful is this bit of code here. There's two methods which are part of the ViewController subclass, I should say, part of the ViewController class. One is view will appear, and one is view will disappear. And basically, when you launch a view on top of your existing view, it fires view will appear just before everything appears, and just before it disappears, in other words, you hit the back button or you press the home button, literally milliseconds before that happens, before the screen disappears, it fires view will disappear. So they're quite good for switching the services on and off to control your location services. Although generally, if your app is in the background, your location services will be switched off automatically for you, but I tend to just prefer to do it myself, just to make sure, rather than trusting the default behaviours. So here we are. Once I've started capturing my location, and I've started capturing my location, at any point I can say self.location.location. So the green location is my object, isn't it? My ACL Location Manager. And there's a property called location. And that returns a CL location object. Okay, it's getting complicated now. And every time you call that, it takes a snapshot of where the user is. So when you're posting stuff back to your service, you'll call this method to capture as they post to the forum, or as they post to your systems. The CL location object itself, okay, so you've got your CL location object. Your CL location object has a coordinate property, which is a CL location coordinate 2D. We'll keep coming back to this one. This is a really useful class. And this returns your latitude and longitude. Okay, so going through, self.location location returns a CL location object, and as part of that, there's a property called coordinate, which returns your latitude and longitude in the CL location coordinate 2D. Okay, that's a structure. That's not an object. That's a structure. That's why there's no asterisks in there. So you can extract your latitude and longitude. So it'd be lat_long.latitude is one property. Lat_long.longitude is another property, and they return floats. Which makes sense, doesn't it? 52 point blah blah blah, minus 1.4, and so on. So there we are. Look, you can log them. As soon as they come in, bang, you can stick them out in the log to make sure they're the right values. So lat_long.latitude, lat_long.longitude, that's the data. If you're going to pass data back to your web service, they're the values you want, aren't they? You want to pass the latitude and longitude. And because they're floats, they will obviously, depending on the architecture of the phone, whether it's 32-bit, 64-bit, there'll be different accuracies. But obviously, fundamentally, the accuracy of the GPS chip is the critical thing here, isn't it? If you're inside a building, 10 decimal places isn't going to help you at all, is it? If it places you outside over there somewhere. Okay, now there is a slight problem with the simulator, isn't there? Because you're on the simulator, there's no GPS chip. If you test this out, it places you, where do you think it places you by default? Any particular place in California? Anywhere in Silicon Valley, specifically? Microsoft headquarters. It places you at #1 infinite loop. The Apple headquarters. Don't worry, infinite loop, it's programming. Basically, but if you don't want to be in California, if you pop up the log screen from the bottom, there's a little button there which allows you to choose different locations. So you've got London, Johannesburg, Moscow, Mumbai, Tokyo. So you can test to make sure your device is tracking the changes. So really, that's all there is to capturing the current location. The core location does all the hard work for us. What we've got to do is just make use of it and try and be a bit sensible about battery usage. Any questions about core location? Is that a... Fine, you can kind of see where you're going with this one. Now, for the demo this week, I haven't used core location, but I have used MapKit in the demo. And like last week, I've actually given you a zip file, which I've put on Moodle. I've given you some sample code. Because I figure by this stage, you don't want to watch me the video going, type in the code in. You probably just want to dive into a sample code that works and pull bits out and see how it fits and try and change it and break it. So I've given you the sample code. So MapKit. Now, interesting thing, MapKit. MapKit is the Apple framework to handle Apple Maps. That's it. But there's a few little twists along the way. You're going to create an array of annotation objects. An annotation is a pin, basically. So when you see all these little red pins all over the map, on Apple Maps, each pin is an annotation object. When you tap on the pin, you get a little, looks like a table view cell, doesn't you? Ironically, you create an MK annotation object almost identical way to the way you create a custom table view cell. It's almost identical code. Seriously, recycling. It recycles the cells, recycles the annotations. So as you pan the map around, just like when you scroll up and down your table view, it's keeping the objects, taking the data out and recycling the objects all the time as you pan and as you pinch and zoom and pan. So you can have thousands and thousands of pins in your map and it will still work at the same speed. Because until the pin comes onto the map, it doesn't load the data into it. So think about this for a minute. How do they handle loading data in the table view cells? Remember that cool method, that third method we used? Remember? Self-arrowed index path. Remember? And as it came onto the screen, it fired up and said, give me the content for this cell in this row in this section. Same thing, same idea. Basically, as it pans onto the map, it calls the delegate method and says, tell me what should be displayed in this particular annotation. And it does it. So what we have to do, we have to create a custom class, which is our annotation object. Because obviously you might have different things in your annotation, photographs, text, labels, and so on. Now, you can't subclass anything. What you have to do, you have to create a subclass of NS object which implements the MK annotation protocol. Like that. So as you can see, there's my interface, my header file for my custom annotation object. And the first thing you notice, I'm subclassing NS object, but I'm implementing MK annotation. You see that? And that MK annotation tells the computer I need to implement certain properties and certain methods. And that's it. So as you can see, the three properties I must have a property called coordinate. I must have a CL Location Coordinate 2D property. But that makes sense, doesn't it? That's my latitude and longitude. I must have a title string, which is the title that appears on the callout. And I must have a subtitle string, which is the subtitle. So it's just like a table view cell, isn't it? Now the trick here is they are read-only. The MK annotation objects are read-only. You can see, look at the properties. Property non-atomic read-only for the CL coordinate 2D, which is not an object. Because it's read-only, I have to create a copy of the strings. I don't want pointers flying around all over the place. I actually want my own copy of the data. But they're all read-only. So the only way we're going to be able to create these is to have a constructor, isn't it? So you build a constructor. So my constructor, I've got 4 properties, so my constructor takes 4 parameters. And I can create my MK annotation objects, or my annotation objects as I've called this class, yeah, using my little custom constructor, which is why we spent so long before on Objective-C and custom classes. Okay? It's all kind of comes around now to bite you. So you have to create a custom class for this. Does that make sense as an interface? And the implementation is really easy. All I've got to do is create my constructor, is implement my constructor. You know, the usual self equals super init, if self, assign the values to the private member variables, return self. So it's not a particularly complicated class, is it? But what's really cool about this is when you tap on one of these pop-over things, these little annotations, it retrieves the annotation object. So you can shove whatever data you want in there. So I've actually added on mine my review ID. This is going to be all my reviews of a particular book. So my review ID from the web service, from the database, I'm sticking that in there as well. So when I tap on it, I get the whole object and I can retrieve the ID, so I can pass that ID to the next screen. And you can shove anything in there. You can shove arrays, dictionaries into your annotation objects, because it's your own custom class. So the implementation file is really easy. The map view is, there's no MapView controller. You simply drag a view controller into your application, as we've done numerous times, and you simply drag a map view into it and use your auto layout just to make sure it fills the space you want. So you have a small one, a big one, full screen, and that's it. Seriously, that's it. Now, you might be wondering, how do I create, I need a segue, don't I, to my next view possibly. How do I create a segue? I can't control drag on the map view because the segue is going to be from my annotation object. How do I create a segue if I can't see the object on the storyboard? We did this before. Yes. Remember when you click on the view at the bottom you've got a little yellow icon in that little tray? Remember you control drag from that across to your next view. And then you can obviously trigger the segue in code. So far, are you okay with this? You can see what's going on. Here's the header file for my view controller. As you can see, look, just a subclass of view controller. I've just got an outlet to my map view, my MK map view. Okay, MK is obviously MapKit. So MK map view is the MapKit map view. So you can see there, nothing surprising, is there? Everything's pretty okay so far. But look, what am I implementing? This is critical. Right, like most controls in Objective-C and iPhone development, there is a delegate. And the delegate is MK MapView delegate. And that's going to be the thing that displays our pins on the map and knows what we've tapped on and knows to trigger the segue to the next view. So here's an example of an MK annotation view on iOS 7. So there's my reviews of one of my books. So there's 3 locations which are EC building, yeah, what else? No, that's EC building, isn't it? Armstrong Siddeley. And where's the third one? No, a bit further along from there. No. It's the art gallery. It's the Herbert Art Gallery on the corner. So sitting there, writing a review, and when I post the review onto my web API, it posts my current latitude and longitude back onto the system. So 3 different reviews, taken in 3 different locations around Coventry. So you can see there is a button accessory view. You can see a little eye thing at the eye button. That replaced the little sort of chevron thing on iOS 6 and before. That's your information button. That's the bit that takes you to the next view. So I'd embed this in a navigation controller. When I tap on that eye button, I'd push another view over the top, which might have the full review, the photograph, the avatar, the book title, and so on. So it's just a nice way. It kind of replaces a table view, doesn't it? If you've got location-based data. So there are 2 really important delegate methods. The first one is what it looks like, how it's displayed. Does it have a button? Does it not have a button? Is it clickable? Does it have a title? Does it have a subtitle? And what gets displayed in it? The second one is what happens when we tap on it. So we're going to launch a view, aren't we? Somehow. We're going to use a segue, and we're going to trigger that segue manually. So So it's simple so far. Now, don't be scared by the amount of code on there. Have a look at it. It should be very familiar. Can you see what's going on there? Look at the first line. MK pin annotation view equals MK pin annotation view, map view, DQ usable annotation view with identifier. Right? You've seen that before. Except instead of DQ reusable annotation, it was DQ reusable cell with identifier. Yeah? It's the same line of code, it's how we retrieve the empty cells. We generated the cell we needed, if there's a spare one sitting around, we use that instead. It's the same idea. If there's no cell available, equals MK annotation alloc in it with annotation, we use identifier. There we go. So if there is no free cell, create one. Create a new one. Okay, this is just like table views, isn't it? And once you've done that, you can just mess with the properties, can't you? Maybe it was title, subtitle before. It's now pin colour. You can choose pin colour. There's a choice about 3 colours. That's about it. Purple, red, and blue. I think that's all you get. You've got if you want a button like the disclosure button, you have to create it. You have to create a UI button. UI button with button type disclosure, and then pin.write callout accessory view equals button, and that assigns the button. You can have any button you want. You can build a custom button. You just have something which is a class or subclass of UI button. And just drops it in for you. Pin.animate drop. You've seen it, haven't you, where the pins drop onto the map, pin in the map. That's just a yes or no. Can show callout means there is a pop over little bubble. Yeah, an annotation that pops out. That can be yes or no. Return pin. That's it. That's all you have to do to create your annotation objects. So it's just like the self-erode index path. Yeah, just like self-erode index path. The great thing about the Apple tools is once they've got something that works, they're not afraid to recycle the same ideas over and over again. If we eventually come to collection classes, the grids, same idea. DQ reusable cells. And the annotation, which annotation's being clicked, this is the last bit of, well, almost the last bit of code. In fact, this is the last bit of code I'm going to show you. Map view, annotation view, a call out accessory control tapped, which is the Apple longhand way of saying they've tapped the button in the accessory. So, look at the parameters. You've got a view, haven't you, which has been passed. That view contains the annotation. So I can simply say view.annotation, and I've got the annotation object that was tapped on. And that's why I store all my junk in that annotation object. Because it's so easy to get hold of it when I need it. So I package all this data into the annotation object, display it on the map, and I tap on the cell on the annotation. I get that annotation object to refer to. So, in fact, to be fair, those 2 lines do the same thing, but let's not pick hairs on this one. Yeah, that's called a sort of deja vu moment there, isn't it? Yeah. Now, look at it. Because I've got a review ID, haven't I? Sort of an integer. I can say int review ID equals annotation.review ID because that was the property I created, the public property. So if I want the review ID, bang, I've got it. But to be fair, you're better off passing the whole of the annotation object into your next view, aren't you? Because then you can unpack at your leisure, can't you? Take whatever data you want out of that. Now, look at the last line. Perform segue with, so I'm calling perform segue with identifier. Yeah, remember I write that method myself, don't I? The sender, I can send whatever I want. I could send that review ID if I wanted to, and that would then appear as one of the properties in perform segue with identifier, in prepare for segue. That makes sense. I'm passing my annotation object. So when I write the method performs, when I prepare for segue, yeah, that annotation object is sitting there ready for me, and I can just open it up, extract the data, or just pass the whole annotation object straight through into my next view. You See how elegant that is? It's tidy, it's neat, everything just kind of fits together. Well, I think so anyway. So really, that's it on the code front. And on Moodle, I've given you a full example shown with the pins. When you tap on the pin, it takes you to the next page. What I haven't mentioned here, but I have put in the example, is something called UI WebView. UI WebView is one of the most awesome views ever built. UI WebView is a web page. Effectively, you embed a web page in your view, fundamentally. But it's actually more than that, because think about how many types of document you can open up in a web page. You can open PDFs in there, images, Word documents, PowerPoint presentations, and you know the pinch and zoom you get on the web page gives you all that as well. So I use it for images a lot. If I've got an image to display, I'll display it in the UI WebView, then the user can pinch and zoom and pan without having to build lots of gestures into it. What I'm doing here is, my review, I'm writing as an NS string with HTML tags in it. And I'm simply assigning that text to my UI WebView. So I can have nice formatting and custom fonts and use style sheets and have a really nicely formatted review by simply building it as an HTML document. You can even load HTML documents from your bundle in your documents directory and display them in the UI WebView. So it's a really useful view to be using in your application. So we've actually covered two related subjects. We've talked about location-based services, kind of where am I, okay, which if you're inside the building could be anywhere between here and the library. And I've also covered MapKit, which is the Apple Maps tool. So you can start adding pins and doing nice views. And remember at the back of your mind that the MapKit, the Apple MapKit, is almost the same as a table view. So when you're displaying tabular data, if you have location stuff in there, substitute an Apple Maps, a MapKit for your table view, because you can do the drill downs and everything else exactly the same way. In fact, when we talk about tabbed view controllers, which will be maybe next week, okay, sometimes a tab is supposed to show the same information in different ways. You might have one tab which shows a table view with everything listed, and the second tab displays the same information as a map with pins in it. So you've got a choice of how you navigate the content. So hopefully that's of some use to you. You'll be able to get some use out of that one. But it all depends on whether you've got location data in your web service, isn't it? If you haven't, you've got two choices. You can either forget everything I've talked about today, or you can very quickly knock up with an extra couple of columns in your database and shove in some lats and longs as floats. I recommend the latter because remember the talk that Tom gave us on 305. This idea of capturing user data. If you've got their location where they are, that data becomes far more valuable, doesn't it? If you know where they're coming from. Well, it's valuable to you because obviously you can then target your services. If you've got lots of people, say, browsing books, particular books in Coventry, you can sell that to Waterstones, and then they can know what books are stocked on their shelves. If people in Coventry are reading lots of 50 Shades of Grey, for instance, and people in Birmingham aren't, they can adjust their stock levels and therefore save money, make more money. So the idea is you build these systems up, you capture lots of data, then you go to these companies and say, I've got lots of data for you. What's it worth? And that's how he's made his money. The apps are almost incidental. The apps are just a way to hook people into giving you data for free. Think Google. When has Google ever charged for any of their software? Even the operating systems they give away for free, because they know the most valuable thing is the data they're getting. And the more popular the software, the more data they're going to get in. And the more data they get in, the more they can flog that data to other companies. The important thing is data is anonymized, of course. We don't want names and addresses on data, thank you very much. But think about the sort of data you can capture in your web service. And if you're canny about this, you'll build some tables, maybe some log tables, and start to grab this data and see if it makes sense to you. Maybe download the data, analyze the data, see if you can see any patterns emerge in there.